Hello guys. So, as you might remember, I'm going absolutely mad with voxel destruction. I just love this mechanic a lot. And therefore in this video I will tell you how to create your own voxel destruction system. Around 1 year ago I already made a video about how to implement this system to your project. However, at that time we used a very inefficient technique. We represented one voxel as a cube, as a separate game object, which is very heavy for the system and inefficient in general. But in today's video I will show you how to create a similar system when voxels are creating a one single mesh, which is more optimized for the system and more appealing to the game. That's as hard as it may get. So I want to warn you that I will separate this video into two parts. In the first part, now I'm drawing the scheme, we will take a voxel file, input it in the C# script, and then we will get the mesh, which will actually visualize our model, our voxels, and also this object, which will be the mesh of our model, will store voxel data. It's very important. Now, moving forward to video number 2. In the video number 2 we'll do a very important thing. So basically we'll take voxel data, which is basically equals to mesh. Let's represent our mesh as a sphere. Just try to imagine a spherical voxel object. Then we will apply destruction onto it. Then we will change the voxel data itself. And this will lead us to rebuild the mesh. And now let's say we have a sphere with a small byte. So part of sphere was beaten off. Yep, that's just how I imagine all this thing. I'm a very bad drawer, I'm sorry for this, guys. Not an artist. Okay, so now moving on to our first script in the system, voxel loader. So I will explain how conceptually voxel loader works. In the inspector you give it a path to a vox file inside the Unity project. The loader opens the file as a binary data. It reads only the essential parts of the voxel format, such as the size of the model, the list of voxels, position plus color indices, and the color palette, if it's present. If the file does not contain a palette, the loader provides a fallback palette. The parsed data is converted into voxel data. That voxel data is passed to a voxel object, the next script in our system, which will handle everything else. So basically voxel loader is the bridge between Magica Voxel and Unity. Voxel data, the core representation of the model. Why do we need this script? Voxel data exists to answer only one question. What does this object look like in memory? And that's very important because memory is one of the key components in this system. Everything else, meshing, destruction, fragmentation, depends on the memory. What voxel data actually is? Think of voxel data as a 3D grid stored in memory. Each cell in this grid either contains a voxel or is empty. Each voxel knows whether it exists, which color it uses from the palette. Important design choice is that the grid is stored as one flat array, not a 3D array. Why? Because it has a faster iteration, better cache usage, and it's easier to loop over during destruction. Those factors are very important for fast processing of voxel destruction. The grid still behaves like a 3D grid, but initially it's linear. It's just easier and faster to read and understand and implement in the system overall. So, long story short, voxel data is the voxel object itself. The mesh is just a visualization of this voxel data, and when we destroy something, we don't destroy the mesh. We basically modify our voxel data. Okay, moving forward to Voxel. Voxel is the smallest unit of our system. Why do we need this script, you may ask? Voxel is the smallest building block of the system, therefore it represents one cell in voxel grid. So in this script we basically write what does the voxel contain. A voxel stores only one minimum necessary information. Only minimum, not the one, there may be multiple essential informations. So is this voxel active or empty? That's the first type of information we need, and the second one is which color from the palette does this voxel use. No transforms, no game objects, no physics, nothing. Just the data about itself. Why it's so minimal? Because there can be millions or billions of voxels on the scene. They are all accessed constantly. Keeping them small is critical for performance. So basically, to explain it in the easiest way possible, a voxel is not an object in the scene, it's just data. The scene object is built from voxels, not other way around. That's important to understand within our system. Okay, so now moving on to measure. Measure is turning data into geometry. The core idea of the script is that the measure looks at voxel grid, finds which faces are visible, and builds a mesh only from those faces. If two voxels touch each other, the face between them is invisible, so it's never added to the voxel mesh. Why it's efficient? The mesher uses greedy meshing. That means instead of creating a quad per voxel face, it merges many adjacent faces into a single large quad. So large flat walls become a few big polygons, not thousands of tiny ones, which really optimizes the system. Because of this reason, the system can rebuild meshes at runtime. Briefly, mesher is like a translator. It translates a blocky voxel world into clean geometry that GPU understands. Okay, so voxel object. Let's say the owner of everything in this scene. Why do I say so? Because voxel object connects voxel data, mesh generation, rendering, and physics. What a voxel object is responsible for is actually holding a reference to the voxel data, asking the mesher to generate mesh, assigning that mesh to mesh filter, mesh renderer, mesh collider, and making sure physics doesn't break when the mesh changes. The key responsibility is safe rebuilding. When the mesh changes, the collider must be updated, the rigid body must not explode, and the object must not teleport. Voxel object handles all of that safely. Basically, voxel object is the manager. it doesn't know how to load files and it doesn't know how to destroy voxels. Its main job is to keep the scene object in synchronization with the voxel data. So, vertex color lead shader. Basically, how the object is rendered. The shader, the normal one, would not work because, let's say, every vertex in our object, in our mesh, may have its different color, which is assigned by voxel data. Therefore, we need the script, more precisely the shader, which will deal with this. So voxel models store color per voxel, not per material. Therefore, shader must read vertex colors, apply lighting, and keep everything simple and fast. What the shader does? It takes vertex colors from the mesh, applies a base color multiplier, adds directional lighting and ambient light, outputs a lead voxel object that matches the Magica voxel colors. So, simply saying, the colors come from Magica voxel. The shader just adds light and shadow, Unity handles the rest. Okay, moving on to setup. First thing we are going to do is we will create an empty game object. Very important because it's empty, doesn't have any scripts, whatever. We put Vox loader on the script, and as you can see, we have the field for path of our project model or whatever. Just I have one of them already here, so we'll just copy it. As well, we have a target object field here, as you can see. So for that, we will just put the voxel object script on this object, and as you can see, we have mesh filter and mesh renderer also added to the object. Now voxel size is the size of voxel in the world units. Let's put 0.2, and also we will put a plate tag. Palette you can get it from downloading any model from Magica Voxel in OBJ state, in OBJ file, and it will give you the palette straight away. As I remember, it has most of the colors your model may use. So in asset path in project, we just paste our model basically, model path, and now we have everything set up. Yeah, we just click these three buttons, go to load voxel, and we click play. Now, as you can see, we created our first voxel model. Of course, it's possible to change it. Let's make it into a castle. Okay, we put castle. Let's make it a bit smaller. So play. Now we have like this big castle, and we will go and just put 0.1. Let's say. Oh yeah, look, tiny beautiful castle. Yeah, super. So as you can see, it works, mesh generates, and that's all. Already half of the way passed. Now in the next video we will just make the destruction. So as the summary for the first video, we can say like that: voxel loader reads the voxel file, voxel data and voxel store the model in the memory. Mesher generates optimized geometry when voxel object owns the mesh and collider, and a vertex color shader renders everything. This system allows us to generate a normal ordinary mesh from voxel data, and it already sets the basis for the future destruction, which we will discuss in the next video. If you want the second part, subscribe to my channel, push the like button, write comments, and just in case, in the link below you can go to my GitHub and download all the source files which are needed for this system. Thank you very much for watching, and see you next time.